Hello, Wiganyo. All right, let's get into today's lesson. Just a thumbs up. Are we all ready? Can I get started? Everyone else who's joining us in a little bit will have to join us where we are. All right. Okay. So we're going to be focusing on paper 1 today. And so we're going to start with the algebra section of it. The reason for this is because I heard quite a lot of people saying something about algebraic fractions. And I just want to make sure we all understand. Oh, I'm sorry, Princess. So there's quite a large group of kids in the lesson who haven't written paper 1 yet, but we will do paper 2 again next week. Okay, so we'll dive into paper 2 again next week. All right. So we're going to alternate back and forth until everyone's written paper 1, and then we'll focus on paper 2. All right. So we're going to start with simple questions, just these questions that we're seeing over here. So I just want you guys to let me know in the chat really quickly, of these 4 questions that we have on the screen at the moment, which one of those can you not answer on your own? Correct, Didimalo, yes. Hi, Sia. Oh, geez. Sorry, Princess. Okay. I just want to check. Can we all answer every one of these questions on our own? Lieutenant, we can't say number 1. Okay, 1.2.3. Okay, that's an exponents question. I totally get that. Okay, 1.2.3 and 0.4. Okay, so I want to now see if you guys can then answer 0.2.1 and 0.2.2 for me. Okay. And when you're ready, then go ahead and pop an emoji on the screen so that I can see that we're ready to look at the answers. So at the moment, we're just focusing on that and that. All right. Sorry, guys. I don't know. Oh, I see. My cords are tangled. So I just need to make sure I'm doing the right things here. Just left and right. There we go. There we go. Hello, Justin. Sure. He's counting. The man is counting. Sure, you guys are closing super early, Justin, because we're closing at the very end of the month. So you guys are very, very early. Yeah, same, Didi Malo, us too. Okay, I'll give you guys about 1 more minute because this particular question is just, this is a 2-mark question and that's a 2-mark question. So it shouldn't take us too long. Hello, Jaden. Okay, we've got less than a minute to go. Sure. Amazing, Mandisa. We'll chat about it in a little bit. Okay, let's just focus on the question here. I think we've got about 10 seconds left. No worries, Desmarie. Oh, that's okay, my darling. It's really not that deep. I'm just glad you're here. Okay, all right, let's have a look at these two questions. Okay, so by now we should know, we learned this in grade 9, that if we've got a squared there, I'm just going to reopen this bracket twice. So I'm going to have x to the power of half minus 3 multiplied by x to the power of half minus 3. And then we're just going to FOIL. So top, bottom, bottom. I should get x to the power of half plus half will give me x to the power of 1. That's just x. And then I'll get minus 3x to the power of half. And then I'll get minus 3x to the power of half again, and then plus 9. Okay. And then I just need, I just need to add like terms. So I'm going to get x minus 6, not 3, minus 6x to the power of a half plus 9. Okay. I don't know if they're okay with the idea of x to the power of a half. So just hold on for me a second, Abu. Let me finish my thoughts. So most of the time, we should know, especially in at the grade 10 level, that anything to the power of a half is just the square root of that thing. Okay, so the square root of x is the same as x to the power of a half. So you could actually also write this as x minus 6 root x plus 9. Okay, I'm not sure which way they want it, so just know that we've got both of those answers available. Okay, so 1.2.2, we've got x to the power of negative 3 divided by x to the power of negative 5. So we need to deal with that part first, because BODMAS, we must do BODMAS. So I'm going to start with x to the minus 3 over x to the minus 5. And now I know that if anything has a negative exponent, it needs to go to the top, the other needs to go to the top, and the other needs to go to the bottom. So this goes down, and that goes up. So technically, I should have x to the power of 5 divided by x to the power of 3 plus, then over here, wherever I see a bracket and an exponent, I'm going to multiply the two exponents together. So I should get x to the power of negative 2 times negative 1 is x squared. All right, so this then becomes x squared. X to the power of 5 divided by x to the power of 3 is x squared plus x squared, which is equal to 2x squared. All right. Okay, how did we do? Did we manage? It's going to be 1 mark there and 1 mark for the final answer. It shouldn't be that difficult. Yes? Okay, so this is the basic algebra part of it that we need to know. Okay, shall we look at question point 2.3 and point 2.4? Just give me a thumbs up if you're able to answer the question on your own. Thumbs down if you want me to help with the question. Okay, I have got 2 thumbs down. Okay, all right, so here's what we're going to do, guys. Those of you who know exactly what to do, go for it. We're going to give you Bikanyo and Tidimalo and I are going to take it a step at a time. Okay, so here's one thing that we know for sure. When we are dealing with variables in the exponent, when we deal with variables in the exponent, we cannot compare exponents unless we have like bases. Okay, so whenever we see exponents, we need to think to ourselves that the bases must be the same. So I need like bases. Now, the problem I'm having here is that over here, I've got a 5, I've got a 4, I've got a 2, I've got a 10. None of those bases look alike. They don't look the same at all. But I do know that some of these can be rewritten differently, right? I know that I can change 4 to something with a power. Correct. We click shift fact on our calculator. Good. So I know I can change 4 to 2 squared. And the reason I would want it to be 2 squared is so that it has the same base as that 2 over there. Okay. I also know that I can go onto my calculator and I can shift fact 10. Let me just check. Thumbs up. Does everybody know how to use the shift fact function on your calculator? Yes, especially Buikanyo and Tidimalo. Do we know how to do that? Okay. No? All right. So on your scientific calculator, you're going to do this. You're going to click 10. Oh, let's try a different number. Okay. So normally in grade 8, they would teach us how to prime factorize. Okay. So it would be that very, very long process that nobody likes, where they'll give you a number. Let's say, for instance, they give you 72. And then you would prime factorize. You would do this. You would go that, and you go divided by 2, that would give me 36. Divided by 2, that would give me 18. Divided by 2, that would give me 9. Divided by 3, 3, 3, 1. And then we would say 72 is equal to 2 cubed times 3 squared. Okay, we would do it the long way in grade 8. Now, what we can do on our calculator that makes this a lot easier is we just click 72 equals, and then we click the shift button, and we look for a button in yellow that says fact, which means the factors. Okay, and your calculator will produce the same thing that ma'am just showed you here. Your calculator will say this. We'll say 3 squared or 2 cubed times 3 squared. Okay, so when we are doing this particular exercise, this one on exponents, if you're not sure, maybe let's say they've given you the number 18. If you're not sure of the factors of 18, use the 18 equals shift fact, and it will give you the answers. Now, this is going to be nice and easy because we know 10 only has 2 factors. They're both prime numbers, right? So 10 can be written as 5 times 2. We know that 4 can be written as 2 squared. All right. So our first step is going to then deal with that first. Everything else stays exactly the way that it is, okay? And then we'll deal with the others first, because we need to deal with the brackets first. So I'm going to leave 5 to the power of x plus 1 exactly the way it is, and I'm going to multiply this with, I've said I can rewrite 4 as 2 to the power of 2. Now this 4 was already to the power of x. So this then becomes 2 to the power of 2x, all to the power of 3. All over, we're going to leave the 2 alone, 2 to the power of 5x minus 2, multiplied by, now 10 needs to change to 5 times 2, but I need to make sure that I leave it in brackets. Okay, and watch how I've strategically given each of those numbers their own exponent, because any number sitting on its own has an exponent of 1. So the next thing to do then, again, just like we saw over here, up here where we had a bracket and an exponent and we distributed, we're going to do the same thing here. So I see a bracket and an exponent, I'm going to multiply in. Same over here, I see a bracket and an exponent. Now, because there are 2 numbers on the inside, that one gets multiplied with x minus 1, and that one gets multiplied with x minus 1. Both of them do. Okay, so we will then get 5 to the power of x plus 1 multiplied by 2 to the power of 3 times 2x will give us 6x over 2 to the power of 5x minus 2 multiplied by 5 to the power of 1 times x minus 1 will just give me x minus 1 times 2 to the power of x minus 1. All right, and now I finally have like bases. I can now work with the things that have the same base, right? Excuse me. All right, so I can see here that my like bases are being divided. What do we do with the exponent when like bases are being divided? We can do that, Abu. Of course, we can do that. Good. We're going to minus exponents, Tidimalo. Lovely. So what I do know is that this, I always minus the top thing. I take the top thing minus the bottom thing. All right. So I'm going to write it in a particular way so that we actually make sure we don't make a mistake. All right. So first, I'm going to deal with the 5s. Let's deal with the 5s because that's easy. So I've got 5 there and 5 there. So I'm going to keep my base. Very, very important that we keep the base exactly the same. We do not, under any circumstances, say 5 divided by 5. No, 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 no. We don't do that. Okay. I just want to make sure. Did you guys hear what I said? Give me a thumbs up. We do not divide the bases. I'm going to kill you. We do not divide the bases. Ever, 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 ever. Okay, we don't do that. Good, Abu, that is the correct answer. Okay, and I'll show you why. Let's take something simple. We're going to take 2 to the power of 4 divided by 2 to the power of 3. Okay, now 2 to the power of 4 is 16 divided by 2 to the power of 3, which is 8. So my answer should technically be 2. If you divide the bases, if you tell me 2 divided by 2, that gives me 1 to the power of 1. My answer is not 1. But we need to keep the base. We keep the base of 2, and then we minus exponents, and that will give us 2 to the power of 1, which is actually 2. Do not divide the bases. You keep, in fact, please write this in the chat for me. I want to make sure we all remember to keep the base. In the chat, please. I'm not moving on. Thank you, Abu. Thank you for keeping the basi. Keep it based. Good. Guys, I cannot emphasize this enough. I've marked so many papers where kids make this mistake. We always, always keep the base. Do not do anything else. Okay, keep the base. So I'm going to keep my base of 5, and then I'm going to subtract top minus bottom. Good, good, Jaden. Amazing. All right, so I'm going to take what I have on the top, x plus 1, and then I'm going to say minus, and then whatever's here at the bottom, I'm going to put that in brackets as well. So I'm going to go minus x minus 1. Make sure. Okay, then I'm going to go multiply that by, no worries, short stuff. Okay, and then I'm going to take the top thing. Again, keep the base. I'm going to keep the base of 2, and then I'm going to take 6x minus, and then I'm going to take the thing at the bottom, put it in brackets, 5x minus 2 minus, there's another one there, another bracket, x minus 1. All right. And the reason I want to do that is because when I'm subtracting, if I subtract, oh, sorry, guys. Okay, if I subtract -1, so if I say 1 minus -1, that becomes a positive. That becomes 1 plus 1. So the reason I leave it in brackets is so that I can distribute accordingly. So now I have to distribute in that direction, distribute over there, distribute over there. Okay, so I will end up with 5 to the power of x plus 1 minus x plus 1. Do you see how that looks a lot different to what we just had? It's important that we do it in the correct order. And we're going to multiply that with 2 to the power of 6x, distribute again, minus 5x, and negative and a negative will give me plus 2. So now it's not minus 2 anymore. And then we'll get minus x plus 1. And now we can add like terms. Okay, let's add like terms. So I'm going to get 5 to the power of x minus x will cancel each other out. So I've got 5 to the power of 2 multiplied by 2 to the power of 6 minus 5x will give us x minus x. The x's will cancel each other out. And then I've got 2 plus 1 left. That is 2 cubed. We don't leave our answer like that. This we can find on a calculator. 5 squared is 25 and 2 cubed is 8. 25 times 8 is 200. All right. Okay, so we don't change any of the steps. Tirimalo, Buikanyo, are we okay with this? Yes? Okay, good. All right. Those of you who were doing this question on your own, did we manage to get 200 as an answer? And be honest. Be honest. Aha. And Sanele, I will tell you, most of the time, it's one of two things. It's either people saying 5 divided by 5, or it's us not putting the bottom thing in brackets. Can we simplify things at the denominator? Lutendo, which denominator? Are you talking about 1.2.4? Are you already over here? 1.2.3, okay. So we don't really have a denominator. Do you mean the base? Do you mean this part? Yes, you must. You must, Lutendo. You can't leave it as 2 cubed. You have to then give us a full answer, because if you leave it as 2 to the power of 3, that's still operational. That's still an operation we can do. So you must simplify the bases. Okay. Oh, Sanela, you can do that, but then it just makes it a lot more difficult. Okay. It makes it a lot more difficult, because let me show you what you can do. You can go 5 to the power of x times 5 to the power of 1 over 5 to the power of x times 5 to the power of -1. Even in this case, this thing has a negative exponent, so you would have to have brought it to the top. Do you understand what I mean? Those two will cancel each other out, and you should have ended up on the top with 5 to the power of 1 times 5 to the power of 1. Does that make sense, Sanele? Mm-hmm. Okay, so if you're going to split it like that, it's perfectly fine. It's just anything with a negative exponent then needs to go to the opposite side. So if it's sitting at the top, if it has a negative exponent, it goes to the bottom. If it's sitting at the bottom and it has a negative exponent, it goes to the top. Does that make sense? Are we okay with that? Okay, amazing. Cool stuff. All right, shall we talk about 1.2.4? Thumbs up. Are we able to answer 1.2.4 on our own? Yes, happy birthday, Narisha. Okay, we'll do it properly at the end of the lesson. Well done for turning. Are we 16? Are we 17? Are we 15? Lieutenant, let me just have a look at that again. 2 to the power of 5x minus 2 plus x minus 1. No. Oh, you mean adding the 2 at the bottom together? Oh, so do you mean doing the operation at the bottom first? Oh, yes, absolutely. Yes, you can. You can multiply those two first and then do the top thing. Yeah, and then subtract. Absolutely. Yes. Sound mathematics. Yeah, you can multiply first. Okay. Yeah. It works out the same, hey? We should get the exact same answer. Well, congratulations. It's quite the milestone. Well done, Narisha. Yes, Narisha is 2 to the power of 4 years old. Oh, lovely. I'm so glad you're really into your exponents, Abu. I love it. I love it. Okay, all right. We wish you a proper happy birthday at the end of the lesson. Okay, let's focus on 1.2.4. I just want to check. Can I erase this? Because I need space. Am I allowed to erase this? Yes? Okay, thank you. And also, if you've missed it, all you need to do is wait for us to upload the video on YouTube, and then you can pause it and write down what ma'am has written. Okay, or follow along again with me. All right. Another check, because we got sidelined by birthday vibes. Thumbs up if you can answer 1.2.4 on your own. Thumbs down if you need help. Okay, all right. So Bikanyo, it's just you and me, really. Okay, everyone else, go for it, finish up. Okay, so Bikanyo, you're gonna have to really have to be in the chat for me, my darling, because I really need you to answer me as we're going. Okay, I'm gonna Oh, excuse me. Ooh. I'm going to try and explain by myself very, very quickly, but I need you to stay with me as we go. Yes, Mandisa, I see your hand is up, my darling. What's up?
Hi, ma'am. I just wanted to confirm. You see the bottom part of 1.2.4. We have to factorize it first, right? In order to continue. Okay.
Correct. Yes. Yes, absolutely. Okay, so I'm going to make a series of statements, and you're all going to know they're true because you've done fractions in grades 4, 5, 6, and 7, and 8, and 9. Okay, so I'm going to say this. If I've got two fractions, let's say I've got 2 over 3 plus 1 over 2. I know that in order to add these two things, I need an LCD, right? And my LCD is going to be 6. How do I know my LCD is going to be 6? Because the lowest common multiple between my two numbers, the lowest common denominator is 6. I've taken 3 and I multiplied that by 2. Now, I want you guys to note that when I do this, the way I get 6 is by taking that thing and multiplying with that thing. And the reason I multiply them together is because they are different. They are two completely different things. They are different. 2 and 3 are not the same number. They don't have anything in common. They are both prime numbers. They are two completely different numbers. Okay. Now let's say, for instance, I do this. If I go 2 over 3 and 1 over 6, my LCD would have to be 6, right? Because I know that 3 goes into 6. So they do have something in common. They have something in common. All right. And don't think I'm weird. I'm going somewhere with this. All right. Okay. Now let's say, for instance, I've got 2 over 3 plus 1 over 9, right? I also know that they have something in common because 9 is 3 squared. So my LCD will be 9. Okay, now, if I take this to the idea of our fractions, let's put it this way. If I have 2 over x plus 1 plus 1 over x minus 2, my LCD would have to be x plus 1 and x minus 2. How do I know that? Because these two things are completely different. They're not the same. Do you agree with me, Buikanyo? Are we okay here? Give me a thumbs up, my darling. Good. We know that they are different. So we have to multiply the two of them to get our LCD. Now, let's say, for instance, I do this. I've got 2 over x plus 1, and then I've got plus 1 over 2x plus 2. Okay. Now, if I want my LCD, I'm not going to be able to see if they have anything in common until I factorize. So I'm going to factorize this part over here. And now I've got 2 and x plus 1. Okay. Now, they do have something in common. Just like 3 and 6 would have something in common. They both have x plus 1 in common. So I don't have to rewrite x plus 1 again. I only have to write it once because they both have it in common. What do they not have in common, Bikanyo? What do they not have in common that I would need to add to my answer? What's missing from my answer that they don't have in common? 2. Good. So I can't just have x plus 1 as my LCD. I have to have 2 and x plus 1. Okay. Lovely. Good. Now, again, let's keep going. If I give you x and I give you x squared, my LCD would have to be x squared. How do I know that? Because within x squared, there is an x. X is inside x squared. Just like when I have 1 over 3 plus 1 over 9, I know that my LCD is 9 because within 9, there is 3. Does that make sense? Yes? Thumbs up? We happy there? Excellent. Good. So let's look at the question we've been given now. Let's look at question 1.2.4. Now, I'm not going to be able to see if these things have anything in common until I factorize that. I need to factorize to see if both of my denominators have anything in common. So I've got 4 minus x, and over here I've got 2x squared minus 5x minus 12. Ooh, no, Hulani, we can't say x. And let me explain why. Let's say, for instance, I've got two values. I've got x plus 1 and I've got x minus 2. If x happens to be 3, if x is equal to 3, this part over here becomes 4, and that part over there becomes 1. These two things are not the same. So they don't actually have x in common. Does that make sense, Hulani? Are we okay with that? Yes? So we can't say the LCD is x because they all have x. No. We are doing other operations to x that does not make them equal to each other. Okay, so no, we can't do that. Okay, so let's factorize. Let's go ahead and factorize. I'm going to leave negative 11 at the top on its own, and then I'm going to factorize that. I know that's a trinomial. Good, good. So I'm going to open two brackets. I know the factors of 2x squared are 2x and x. I need the factors of 12 that will give me negative 5x. Okay, one of them will have to be multiplied by 2. Now I know 12 is 6 times 1. And so if I put the 6 over here, what's going to happen is I'm going to go 2 times 6, and I'm going to end up with 12, but then I still have to minus to get to 5, and I count minus 1. If I put 1 over here, I'm going to get 12 minus 1. That's going to give me 11. So that's not going to work. Maybe I switch them around. Maybe I put 1 here, and I put 6 here. Now I know that 2 times x, or 2x times 1, will give me 2x, and then 1 times 6 will give me 6x. Sorry, oh, why am I lying? 6 times x. 6 times x will give me 6x. That will give me minus 4x. So 6 and, guys, why did I use 6 and 1? And why is nobody correcting the teacher? Guys, why did I just say 6 times 1 is equal to 12 and everybody's quiet? Come on, guys. Help me out, guys, help me out. I know, guys, come on now. 6 and 2. 6 and 2, guys, 6 and 2. Nah. Okay, you guys can punch this into your calculator. I'm quickly going to work it out in my head and see if it works. 4 minus 3. 4 minus 6 doesn't work. Nah, 9 minus 4 works. So I can put 3 here. I can put 3 here, and I can put 4 there. And then I'm going to make this negative, and I'm going to make this positive. Hi, well, guys, you can't always think I'm correct, guys. Come on, Namusa. Okay, there is my factorization. Right. Okay, this minus 1 over 4 minus x. All right, Bikanya, let me ask you. Do my denominators have anything in common? Oh, no, guys, I'm lying. Again, I'm lying to everybody. No, they don't. Okay, so this will be 4, and that will be 3. Okay. They don't have anything in common. Sorry, guys. Sorry. It's been a long day, okay? It's been a long day. I'm very sorry. Okay, but let's have a quick look. I can see over here that I've got an x minus 4, but on this side, I have 4 minus x. Right. So I know of a rule that we learn in grade 9, right? We can do a sign change. Remember how we do a sign change? Yes, I call it a switcheroo. I don't know what your teacher calls it, but in mathematics, it's called a sign change, right? And we normally do it when we're factorizing common bracket. So if I have 4 minus x and I have plus a over here, if I want to swap these two things around, I just make this plus a and negative a, and then I switch those two around, and I go x minus 4. Okay, so I can see that they're very, very close to each other. They're quite close to each other. That's x minus 4. That's 4 minus x. So what I'm going to do is I'm going to change this minus here in the middle to a plus. And then I'm going to take 4 minus x and I'm going to switch it around to x minus 4. Okay. Bukanya, are you okay with what ma'am has just done? Are we all right with that? Everyone else, are we good? Are we good? Good. Amazing. All right. Now, can you tell me in the chat, what do they have in common? What do they have in common?
X minus 4.
Amazing. Good. So I know my LCD is going to be x minus 4. What else do we need to add into the LCD to make sure that our LCD is complete? What's missing? What else is missing, my darling? Remember, we must include everything.
2x plus 3.
That's it, my darling. So we must have x minus 4 and 2x plus 3. We must account for everything. Okay, there we go. All right, and then we just do what we do with normal fractions. If I had 2 over 3 plus 1 over 2, I know that my LCD is 6. If my LCD is 6, I'm going to ask myself, what did I do to 3 to get to 6? Times 2 at the top. Over here, I need to times 3 at the bottom, times 3 at the top. Right, so we're going to do the exact same thing. Now, what I'm seeing in the first bracket is that nothing is missing. Sorry, in the first fraction, nothing's missing. I've got x minus 4, 2x plus 3, and over here, I've got x minus 4, 2x plus 3. So nothing is missing. I don't have to change anything at the top or at the bottom. So I'm going to leave negative 11 there. All right, so Bikanyo, tell me, my darling, what's missing there? What's missing in this denominator? From our LCD, what's missing?
2x plus 3.
Good, 2x plus 3, amazing. All right, so I now need to go in and multiply this side by 2x plus 3. And what I do to the bottom, I must also do to the top, 2x plus 3. Okay, so I'm going to get negative 11 plus 1 times 2x plus 3. If I distribute, I'm just going to get 2x plus 3. And then we're just going to add like terms. Okay, let's add like terms on the top. I'm going to get negative 11 plus 3. That will give us negative 8. So I'm going to get 2x minus 8 over my denominator, x minus 4, 2x plus 3. But I see something over here. What do I see at the top? What do we notice at the top? I can take out. Good.
Highest common factor.
Of how much? Look, of 2, right? Good. I know that my highest common factor will be 2. So at the top, I'm going to end up with 2, open brackets, x minus 4, over x minus 4 and 2x plus 3. But remember, we must still treat this thing as a fraction. So I know that if I can cross cancel something top and bottom, I just do that. Cancel, cancel. So my final answer is 2 over 2x plus 3. All right. How do we feel about that? Are we okay with that, Bikanyo? I know it's a long process. It really is a long process, but we need to be okay with the steps that we need to take in order to get there. We're doing the same thing we would with fractions. All right. I just want to double check with you guys. Do we want to do something similar to this, or do we want to move on? Just let me know in the chat, please. Okay, Didimalo says similar. Okay, move on. Ooh, it's looking like the similars might have it. Okay, here's what I'll do. Okay, I'm going to move over to the side. Okay, one for good measure. Sure, we can do one for good measure. Absolutely. All right, here's your next challenge. All right, these 3 questions. Okay, hello, Gift. It's lovely to see you too. Okay, these 3 questions are exactly the same as the ones that we did there, right? Okay, so let's go ahead and see what we can do with what we've got at the bottom here. All right, so I want us to do it in this order, actually. Let's do this. Let's do this number one. Let's do this one first, and then we're going to go to this one second because we did exponent seconds, and then we'll come back to the one in the middle because that's the last one we did. All right, I'm going to give you guys a few minutes. Let's say about 6 minutes to do number one and number two. All right, go for it, guys. All right, peeps, are we ready? Shall we chat? Or do you still need a few seconds? Okay, Sanela's ready. Everyone else? Okay. All right, amazing. Let's look at the first two. These are quite easy. Now that we've done the others, they should come quite okay. Again, just distribute top, bottom, bottom. Okay, this is going to give us x cubed minus 3x squared plus 9x plus 3x squared minus 9x plus 27. Okay, and then we can already tell if you had looked at it really, really properly, you would have noticed that it's a cube. It's the factorization of a cube. So some kids would have already recognized that and just done that. X cubed plus 27. And that would have been fine. They would have given you your 2 marks. Okay. All right. So negative 3x squared plus 3x squared cancel out. 9x minus 9x cancels out. And your final answer is just x cubed plus 27. But that's also something you can notice. Okay. All right. Let's skip number 0.3.2. We'll come back to that. Let's go to 0.3.3. Okay. Remember what ma'am said. Again, if you want to compare exponents, we need like bases. So that's what we're going to start with. We're going to start with making everything like base. Okay. So I know 10 is going to turn into 5 times 2, and I'm going to give each of them their own exponent so that I remember that both of them must be multiplied, or both exponents must be multiplied with 2 times x. I can change 4 into 2 squared, all of that to the power of negative 1 minus x, all over 25 can be written as 5 squared to the power of 2 plus x, not 2x, 2 plus x. 2 plus x. All right. Then the next thing to do is to just get rid of the brackets. I'm going to distribute, distribute, distribute. Now be very careful, guys. Don't just write, okay, this one is going to be easy. 5 to the power of 2x plus 3 times 2 to the power of 2x plus 3, because we're multiplying each of them with 1. That's easy. Over here, where we're multiplying by 2, you need to actually do that. Okay, we need to distribute like we would when we're multiplying a binomial by a monomial. So I'm going to get multiplied by 2 to the power of 2 minus 2x. Okay, over, and then we get to the bottom. I've now got 5 to the power of 4 plus 2x. I'm going to read your question. Let me see what you said. Ma'am, can I ask in point 1, aren't we adding the like terms? I'm kind of confused. Okay, yes, absolutely we are. We can add the like terms, Biganyo, but look at them. Look at the like terms carefully. I've got negative 3x squared plus 3x squared. That's going to give us 0. Those two are going to cancel each other out. And then I've got 9x minus 9x. That's 0. Those will cancel each other out. So the only thing I actually have left is x cubed plus 27. Are we okay with that? You can unmute, my darling, if you're having, okay. I see you've got your hand up, so I'm not sure if you meant hand or if you meant thumbs up. Okay, all right, there we go. Okay, all right, remember to distribute, guys, down here, we're over here. So distribute, so we'll get that. Okay, I know some of you guys are, yeah, we're going to take these two here, and we're going to multiply them because they're sitting right next to each other and they're being multiplied. So these other two down here, these are like bases being subtracted, and the other two are like bases being multiplied. So this is going to equal, I'm going to start with the 5s. Okay, remember, keep the base. Keep the base. So 5 to the power of 2x plus 3, and then minus, add a bracket, 4 plus 2x, close bracket, multiplied by 2 to the power of, these two are being multiplied, so we're going to add them to each other. So we'll get 2x plus 3 plus 2 minus 2x. And I don't need to put that one in a bracket because if you multiply anything by a plus, it stays exactly the same. All right. Then I'm just going to distribute. I need to remember to distribute. So I'm going to get 5 to the power of 2x plus 3 minus 4 minus 2x multiplied by 2 to the power of, I'm going to get 2x minus 2x will cancel out. And then I'm going to get 3 plus 2, so 2 to the power of 5. Okay, let's clean up this other one over here. 5 to the power of 2x minus 2x goes away. And I've got 3 minus 4 left. So 5 to the power of negative 1 times 2 to the power of 5. And remember, you can't leave these looking like this. We need to change the form, which then becomes, that becomes 1 over 5, because we can't leave it with a negative exponent, multiplied by 2 to the power of 5 is 32. And that then becomes 32 over 5. You can skip this step, though. You don't need this step. Okay, you don't need the step. You can just take this, punch it into your calculator, and give your teacher an answer. Yes, Justin, these come from an exam. They come from the 2022 exam. Okay, the first ones that we did were from the 2022 exam. These are from the 2023 exam. Okay. Sure. All right. Let's talk about 1.3.2. I just want to gauge who can do this. Who can do 0.3.2 on their own and be okay? Abu? Anyone else? Sanele, good. Lutendo, good. Theo, Narisha, no. Okay, we can try it. Okay, now the one thing we know for a fact about algebraic fractions, whether we are multiplying, dividing, adding, subtracting, is this is all a factorization game. It's all it is. It's just factorize, factorize, factorize. Before we even get to factorize, factorize, let's talk about how that is 1 minus x squared, and that is x squared minus 1. We already know what we need to do there. Yes? Okay. We know what we need to do. We did it in the question before. Before the LCD, what can we do, Tidimalo? They look very similar. It's just that one is, they're in opposite directions. Before we do dots, correct, we can swap them around. Good. We can do a sign change. That's it. We can do a sign change. Before we get started, we can do a sign change over there. To make this part, instead of 1 minus x squared, we can make it x squared minus 1, so that it looks like that one. And then we will have something in common in our LCD already. Okay, are we okay with that idea? Are we okay there? Excellent. All right, let's start there. And then all we're going to do is just go through this entire thing, guys, and just factorize everything. Factorize absolutely everything. Just factorize, factorize, factorize. Factorize. Okay, I'll give everybody 4 minutes to factorize everything. Factorize the top, the bottom. After the sign change, factorize, just factorize. Okay, and then you'll see, this is why this question is only 4 marks. It's not 6, 7 marks, just 4. Because it gets really, really easy once we've factorized. Yes, there is, Lulani. There's a cube. There is. There. X cubed. So you must remember how to factorize a cube as well. Right. It's so easy, Gift. So easy. So nice and easy. And honestly, guys, I feel like these lessons should be two hours long and not just an hour and a bit, because we are almost out of time, and there's quite a bit more that I wanted us to do. Four hours max, Aibo, guys. Hey. Oh. Night shift. I think they call it cross-nighting, Theo, where you like bring your sleeping bag to school and you stay up all night studying and working. Ooh, I can't do those things. I'm old, guys. I'm in bed by 7:45, like 7:45, guys. 7:45, it's lights out. I don't have time for those things. All right, shall we look at the question? Yes, I wake up very early, Tidimal. I'm up at 4. I'm up at 4. So you can imagine, I don't want to be grumpy and groggy at 4 a.m. So I go to sleep early. Okay, let's start with our factorization, because this is going to be nice. Okay, what did ma'am say? What is the default setting? What is the first thing we always check for? Thank you. Every single time we check for that first. Okay, so I can already see before we go through here that this first one over here has an HCF of x. The one here at the bottom, this is a cube, so I need to know how to factorize a cube. That one over there, again, HCF. Okay, I can't factorize that one. There's no need. There's nothing for me to factorize. We said that we'd swap this one around, so we'd make that a 1, a minus, and then we'd swap this to x squared minus 1, and I know that this is dots, and because this and that look exactly the same, this is also dots. Okay, so let's get to work. It's a lot of work to do, or it's just bothersome and tiresome because we're doing the same thing again and again, but let's go ahead and see what we get. I'm going to take x out as a common factor. I'll get x squared plus x plus 1 over there. And then at the bottom, I know that this is a cube, so I'm going to open a small bracket and a big bracket, and then I'm going to cube root that, so that becomes x, and that becomes minus 1, and then I'm going to square. X squared and negative 1 squared will give me plus 1, and then I know that I will have x times negative 1 will give me negative x. When I put it in there, I need to put it in with the opposite sign, so plus x. Please tell me you guys already see what's going to happen here. Minus, do we already see it? Yes. Okay, let's go to the top there. All right, I'm going to take out an HCF of 2, and I'm going to have x plus 1 at the top. At the bottom, I've got x squared minus 1. I know that's dots, so 2 brackets, x minus 1, x plus 1. There's another one. Plus x plus 1 at the top. I can't factorize that one. There's another dots, so open 2 brackets, x minus 1, x plus 1. How nice. How nice does this thing look now that we're really looking at it? All we need to do is just cancel. But remember, guys, you can't cancel like that. Why can I not do that? Why can I not cross cancel? No, it's not because they're not the same term. When do we cross cancel? When my fractions are being what? No, it's not illegal. Well, yes, technically it is illegal. Good. We only cross cancel when we are multiplying, or if we divide, we'd have to KFC, we would have to tip in times first. But we only cross cancel when we are multiplying. We are not multiplying here. There's a minus there. There's a plus there. So the only 2 things I can cancel are these 2 things. I can cancel that and that because they're in the same fraction. Okay. Then I need to go to the next fraction and see. Yeah, sure, Justin. Absolutely. I had every faith in you. I knew you were going to say that. It was coming. We just needed to give it some time. Right? It was getting there. We were getting there. All right. So x plus 1 will cancel with x plus 1. On this side as well, x plus 1 will cancel with x plus 1. Now, let's write down what we have left. I've got x over x minus 1 minus 2 over x minus 1 plus, now, because that thing is gone, it doesn't mean it's disappeared. What's actually in the place there? What's actually in place there? What number? Good, it's a 1. Yeah, that's it. It's 1 over x minus 1. Look at that. Look at our LCD. How beautiful is our LCD? Right, so we now know that our LCD is x minus 1. So over all of this over x minus 1. Now they all have the LCD, so they all have the LCD in common. So my final answer is x minus 2 plus 1, which will give me x minus 1. Are we in agreement? Negative 2 plus 1 will give me x minus 1. How? X minus 1. Look at what's happened. Look at how beautiful this is. Guys, I'm not going to lie. The satisfaction I feel when mathematics works out so beautifully. It's just like chef's kiss, guys. Oh, it warms my heart, guys. Do you know how nice it is to just like look at a question and be like, nah. But when it doesn't, okay, that's fair. That's fair, Tidimana. That's very fair. But this was just, just so molto bene. Hey, guys, every time I'm having a good time, fake Italian just comes out because I don't know, guys. I really do need to learn Italian because I always speak fake Italian and it's not good. All right. Okay, are we comfortable, everyone? Okay, do you see? Factorize. Shall we move? Let's talk about inequalities very quickly. I don't want us to do that. Oh, thank you, Abu. I didn't know you'd found out. But yes. But yes, it was yesterday. So that's quite okay. Thank you very much. I appreciate it. Okay, let's look at this question over here. Is that what we say, Sanele? I like that. All right. Okay, let's look at this inequality over here. We are given -1. We know that it's an inequality when this and that are there, right? That's less than or equal to and less than. Oh my goodness. I love it though. I really do. I love it. No, Musa, I'll show you. I'll show you how. I'll explain it to you. Okay, at the end of the lesson, I'll give you the secret. Hey? Okay. All right. So first thing it says, the first question says here, solve for x. Thumbs up. Do we know how to solve for x here? Everybody okay with how to solve for x? Okay. All right. I'm going to give you guys a few minutes. I'll give you 3 minutes because that's what they've given us. A mark a minute. 3 minutes. Solve for the inequality for me, please. Well done, Biganyo. I'm sure everybody else will finish in just a second. Doesn't take that long. Yeah, there we go. Amazing. Awesome. All right, I'm going to solve it very, very quickly. Okay, I'm going to take the 1 over to the other side. I'm going to take the 1 over to the other side as well. So -1 on both sides. That will give me -2 less than or equal to -2x over 3 less than 4. Right. And now I want to get rid of this 3 at the bottom there. So I'm going to multiply this side by 3, multiply that side by 3. So I'm going to get -6 less than or equal to negative 2x less than 12. And then I need that negative 2 all its own. So divide by negative 2, divide by negative 2, divide by negative 2. I want the x all its own. So I should get 3 less than or equal to x less than or equal to, less than negative 6. Has anybody spotted the problem? Anybody see it? The signs, yes. I don't know, I'm not so sure about the signs, but it has absolutely everything to do with the fact that 3 is not a smaller number than negative 6. Okay, so what I need to now do is I need to swap this thing around. We have to, oh guys, our lights just flickered. That's not a good sign. Good, we need to swap, right? But we can't just swap the negative 6. The sign that goes with it must go with. All right. Okay, so the inequality must also go with it. So I should get, therefore, negative 6 is less than x, which is less than or equal to 3. Okay, not the sins. The sins. All right, that's question 1, 2.2.1. Let's look at point 2. It says, write down the number of integers that will satisfy this inequality. Now, we know integers need to be numbers. Okay. When do integers get satisfaction? Okay. So if we think about it, if we had to draw this on a number line, I would have an open dot at negative 6, and then there'd be numbers, and then I would have a closed dot at 3. Right. So if this was real numbers, if this was all real numbers, then I would just be able to do that. I'll just be able to join those two. Right. But this is not real numbers. It's not. It's integers. And we know that integers are positive and negative whole numbers. So I know I can't include negative 6. Why not? There's an open dot there. So I need to think of all the numbers in between there. Good, Abu, that's it. So we will get negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, and I must include 3. That's a closed dot, and 3. No, he didn't pull it out of nowhere. I was actually very good at maths. Okay. All right. He just pretends he's not good at math, but he is. So that's the answer they're looking for. I just want to check. Is everybody okay with the process ma'am has gone through here? Yes? Thumbs up. Are we good? Yes? Okay. This particular part here, this should be common knowledge. Okay? It should be something that you already know. There's no way on this planet Earth that negative 6 could be a bigger number than 3. Okay, remember the crocodile mouth. Okay, so make sure that you're doing all the right things. Shall we look at simultaneous equations? Simultaneous equations? True, Sanele, I agree. Okay, good. All right, let's look at this simultaneous equation over here. Well done, Abu, for actually starting. Should I be helping? Should I be helping with this question? Does anybody need help? Okay, all right. Okay, let's just do a quick recap. I'm actually going to move this over to the side because I want us to do it separately from everything else that's happening on the screen right now. So let's move all the way over to the side of town. All right, okay. So there are two factorization techniques, not factorization, simultaneous equation techniques. Yes, there are two of them. There is substitution What's the other one called? Substitution and difference. No. It's called elimination. That's it, Lutendo. Elimination, which does constitute a difference, but not quite. Okay, if it needs a difference, then you subtract. Sometimes it needs addition, and that's why we just call it elimination. All right, so when do we use substitution? As soon as we see that they've isolated one of the factors, like if there's just an x or just the y on its own, then we use substitution. Right. Elimination is when everything is 2x and 3y and 5x and 7y. Then we know that we must use elimination because then that requires more steps. So if we look at this over here, are we going to use substitution or elimination? Which one should we use? We must use sub, right? We can use substitution. How do we know this? Because there's an x there. There's negative y there. We can move things around to get where we need to go. Okay. Yes, subs, always subs, not dubs. Boo to sub, to dubs. We don't do dubs. We never do dubs. Okay. All right. So first thing we're always going to do, guys, is we're going to label our two equations. So equation, oh, I'm lying. I must first write this equation out. I'm going to go x minus y equals 4, ... equation 1. And then I'm going to go x over 5 plus y over 2 equals 5, ... equation 2. All right. Now, because we're using substitution, we want to isolate one of these factors. So I'm going to isolate x. I want x on its own. So everything else, other side. So negative y must go to that side. So I'm going to say in equation 1, x is equal to 4 plus y, ... That now becomes equation 3. That's equation 3. Now, let's have a look at this next equation over here. If we look at equation 2, what do I notice? What kind of algebra do we have there? We have what? Anybody got an idea? It's a fraction. It's a fraction. It's two fractions being multiplied. I'm sorry, being added, right? So we must find an LCD. So in equation 2, our LCD, what is our LCD, guys? I'm just going to put 5 over 1. Good, our LCD is 10. Right. So I know I'm going to multiply by 2, multiply by 2. Over here, multiply by 5, multiply by 5. Over here, I've got 5 over 1, so times 10 times 10. Let's rewrite equation 2, and we're going to name it equation 4. So I'm going to get 2x over 10 plus 5y over 10 is equal to 50 over 10. This is equation 4. But here's the nice thing. When we are solving algebraic fractions and we get an LCD, as soon as everything's been multiplied with the LCD just falls away. We just remove it. We don't need it anymore. We can just compare the top. All right. So now I've got equation 3 and equation 4. Now we're going to sub in. So we're going to say sub in equation 3 into equation 4. Now, what this tells me is that because equation 3 says x is equal to something, wherever I see an x in equation 4, I'm going to replace x with 4 plus y. Thumbs up. Are you guys able to do that for me? Are you able to do that? I'll give you guys a few minutes. Solve for y for me, please. We're actually out of time, but let's just go ahead and do it. All right. Let's stay on for a little bit longer. Yes, that's fine, Abu. That's fine. I will give. I'm not holding anybody hostage. Okay. But also, you can't leave. Like you're just not allowed to leave. I know you will. You will, Abu. By actually study. By actually study. Okay, we'll have a look, Sanele. Let's see. Okay. Oh, there we go. Abu's got the answer for you. Good. All right, let's have a look. Okay, so if I sub 3 into 2, I can see here, 3 into 4, equation 4, I see 2, and then immediately I see an x. So I'm going to replace x with 4 plus y. So 2, open brackets, 4 plus y, plus 5y is equal to 50. I'm going to distribute, so I'm going to get 8 plus 2y plus 5y is equal to 50. I'm going to take this over to the other side there. Then 2y plus 5y is 7y is equal to 50 minus 8 will give us 42. And therefore, y is indeed equal to 6. Okay, which is nice. Very nice, because now we know what y is, and we can just go back into equation 3. We can go back to equation 3 and look for x. So we're just going to go x is equal to 4 plus, we know what y is. We've just calculated for y. So y is 6, 4 plus 6. Therefore, x is equal to 10.